Hi there. Welcome to this lesson on proportions. As always, like this video if you find it helpful, subscribe for more math content, drop a comment, question, and check out some of the other videos on the channel. Now, I love proportions, and one of the reasons I love them is because they are so useful. It's not one of those more obscure things in math where you sit in class and you're wondering, why would I ever need to know this? And you will stumble across proportional relationships all over life outside of your math class. It also spans several different courses. So you first introduce proportions usually at a middle school level or pre-algebra level, and then you explore them more deeply as you progress through your math journey. So this lesson is going to assume that you know how to solve linear equations. I'm not going to dive into quadratic equations because I'm aware that folks watching this video might be in a pre-algebra class, in which case you wouldn't know how to solve quadratics. But if you're an Algebra 1 student or an Algebra 2 student, then we can kind of up the level in what we put in those proportions. So we want to talk about what is a proportion and what does it mean for two quantities to be proportional. So we're going to start off with the idea of equal ratios, okay? And remember that a ratio is comparing two numbers. So we have here several examples of equal ratios. We have 1/2 or 1 out of 2 is the same as 3/6, or 3 out of 6 equals 5 out of 10. And what we mean by that is we'll use the good old pizza analogy. So I have two pizzas here. If I take one of them and I divide it into two equal pieces, so the bottom number in the ratio tells me how many pieces I have, and I take one of those pieces, that's how much of the pizza I have. If I take another pizza and I divide it into 6 equal pieces, okay, and I take 3 of them, when we say we have equal ratios, what we mean is that in both of these scenarios, we have the same amount of pizza, okay? Half of a pizza and 3/6 of a pizza would be the same total area of pizzas there. And that's what we have, that's what equal ratios are. Now, if I had to come up with just the shortest definition possible for a proportion, I would say a proportion is two equal ratios. Okay, two things that we know have the same ratio. Now, to find equal ratios, essentially what we do is we multiply or divide by the number 1 in the form of k over k, where k is just a number. So I'll show you an example of that. Suppose I have 3 over 4, and I want to find another equal ratio for 3 over 4. I'm going to pick a number, and I'll pick the number 5, okay? And I'm going to multiply by 5 over 5. Now, 5 divided by 5 is 1. So 3/4 times 1 is going to be 3/4. But according to my laws of multiplying fractions, I'm going to multiply straight across. So 3 times 5 is 15. And 4 times 5 is 20. And what I have done there is I have found an equal ratio. So 3 out of 4, or 3 out of 4 pieces, would be the same as taking 15 out of 20 pieces. So that is what we mean by the equal ratios and how we find equal ratios. So when you're finding the equal ratios, you'll always have some kind of factor of k multiplied in. You could also say divided by, that would be the same as multiplying by some kind of reciprocal, okay, to find them. So when we say two quantities are proportional, what we mean is that the ratio relating them is always the same. Okay, and so we'd have one ratio and then another ratio, and the ratios might look different, but they would indeed be equal. So again, I said definition of proportion would be two equal ratios, and to say that two things are proportional means that the ratio from going from one to the other will always be the same no matter what it looks like. So here's a key idea. In proportions, cross products are equal, okay? And this is why I wanted to go through the how do we come up with equal ratios. So let's see why. Let's take a peek at why. So let's say you've got A over B, and you want to find an equal ratio to A over B. Well, we know that I can find that equal ratio by multiplying by some number K, okay? And I just did that with the 3 over 4. Okay, we had this one, 3 over 4 was equal to 15 over 20. And so that's how we find them. Now, cross products, literally, they look like a little X. That's why we call them cross products. It's also called cross multiplying. And this is the only time you should cross multiply. If I cross multiply, going along one side, I have A times K times B, and going in the other direction, I have B times K times A. But what we know about multiplication is that it does not matter what order you multiply in. So we could just say like KAB equals KAB. And so what we know about that is if two things are proportional, then the cross products will be equal. And I'll just illustrate it over here, okay? I have 3 over 4 equals 15 over 20. So if I cross multiply, I should get 3 times 20 equals 4 times 15, and I do. And that would be true for any proportion, okay? Any pair of equal ratios, the cross products will be equal. How do I know they will be equal? Well, because of this. It's because of how we find equal ratios in the first place that we know that the cross products will be equal. So this means that we can find the missing value if we know the other three. So if you know this value, and this value, you can find the missing one. Or if you know this one, and this one, you can find this one. And it doesn't matter where the unknown is. And this was an issue that I had many, many years ago now when I was teaching middle school is teachers that I worked with that I respected, but they would teach a very formulaic way of solving proportions that a lot of times students did not understand what I just went through with you, which is this like idea that cross products are equal. And what's so powerful about that is you're not going to be bound by where your unknown is. You can put your unknown in any of those 4 positions, and you can also mess with the unknown. So if it's an X, you're great, but if it's a 3X, it would still work. Or if it's X plus 1, it would still work. And so we really want to have that key idea grounded that cross products are equal. And if we have 3 of them, we can find the missing one. So now I want to spend the rest of the lesson pretty much going through some examples. What are some examples that you might see of proportions? So I am an avid runner. A lot of times I'll set a video to process and I will go out for a run. Okay, this is what I do to manage stress, to stay healthy. And so sometimes I run races, and anyone in the running community knows if you go sign up for a 5K race, okay, which is generally one of the shortest races you can sign up for. Sometimes you can find some that are a little bit shorter, but 5-kilometer race, you will be running 3.1 miles. And quite frankly, I don't know the conversion factor between miles and kilometers the way that I would see it if I looked it up online, but I do know that because I run. So I know 5K. Okay, we're in it for 3.1 miles. So here's how we can use a proportion. If 3.1 miles is equal to 5 kilometers, how many kilometers is in 5 miles? Now, when you set up your proportion, your ratio, it actually does not matter what goes on the top of the ratio and what goes on the bottom of the ratio. It does not matter, because remember, we're going to end up cross multiplying. So not going to matter. However, once you pick where you want to put it, you can't change your mind about it. So let's say I decide I'm going to put miles on the top of my ratio and kilometers on the bottom. So I know, because of running a lot, that 3.1 miles is equal to 5 kilometers. Now, this is where you can't just change your mind. How many kilometers? So my unknown is the kilometers. So I decided I was going to put kilometers on the bottom. How many kilometers? That's the thing I don't know. That's where we'll put our X. And we decided to put miles on the top. And here we have 5 miles. And so we'll put 5 miles on the top like that. And that sets up our proportion. And you do have flexibility with that. So if you wanted to put kilometers on the top and miles on the bottom, okay, you could have 5 kilometers is 3.1 miles. Therefore, how many? Now your X would go on the top there and your 5 miles would go on the bottom. So what I mean by you can't change your mind is you can't set up one of the ratios to be miles over kilometers and then the other ratio to be kilometers over miles. Like you just have to be consistent, but you can set it up either way. And what I know is that the ratio between miles and kilometers is always the same. Like those are hard units, okay? So whatever this ratio is, this would have to be the same ratio. And we're going to use our cross products to solve. So 3.1 miles times X, and I'm going to do something with the units here. So 3.1 miles times X is equal to 5 kilometers times 5 miles. And I think this is really cool. What you can kind of do here, okay, I'm going to erase this in a second, is you could divide both sides by just miles, okay? And miles over miles would be 1. Now that's like a little bit slick to do there, but it leaves us with 3.1x, and then 5 times 5 is 25. And your kilometers is still sitting there. Remember, we want to get X by itself, so we'll divide both sides by 3.1. 3.1 divided by 3.1 is 1. And then I dropped my notebook where I had the answer to that. So I'm going to have to redo it. A second. My apologies. Usually, like I have that ready. I do have it done out, but I dropped it on the floor. Okay, 8.06. So 8.06. And notice the kilometers are right there. Now, most of the time when I do this, I do not carry all those units through. Okay, I just don't put them there. But we have like a little note over here. Note how we can treat the units like variables. That is something called like a unit analysis, where you just throw all the units into your algebra, like with the numbers, and treat the units like variables. In other words, like they can cancel out. You can add or subtract like units, and it also serves as kind of a check. So if you know your answer was supposed to be kilometers, how many kilometers, you'll end up with kilometers in your answer. So a very powerful thing to do. Don't have to do it all the time. Now, let's say you set it up like this one up here in the upper right. Well, notice when you cross multiply, you'll have 3.1 miles times X equals 5 kilometers times 5 miles. And you'll notice it ends up being the same thing. Again, you just have to make sure that you're not flipping one of those ratios when you go to write the second one. Right? So unit conversions can convert anything. Currency exchange. Okay, so this is another example of something that's proportional. And I went and I looked this up. My church used to do a lot of mission trips to Nicaragua. So I've got Nicaraguan Cordobas in my wallet, and I would take them out, use them as an illustration. I went and looked up the currency rate. So if $1 is equal to 36.85 Cordobas, how many dollars do you need to exchange to get 500 Cordobas? So if you're in a market, you want to buy something, so you need to exchange some of your American money, and you want to know how much American money do you want to exchange. And so here's our ratio. So we got to pick how we want this to go. So we can put dollars on the top and Cordobas on the bottom. So $1 is 36.85 Cordobas. And again, does not matter if you set it up that way. You can put Cordobas on the top, dollars on the bottom. Be totally fine. You just cannot change your mind when you go to write the second ratio. So how many dollars do you need to get 500 Cordobas? Well, 500 Cordobas are on the bottom, so the 500 goes on the bottom. and the unknown, the x, goes on the top, and we will cross multiply because we know that that ratio between Cordobas and dollars is always the same. So if we know that those are the same ratios, we can use cross multiplication to get there. So 36.85x is equal to 500 times 1, which is just 500. So I'm going to go ahead and erase that. Maybe I'll go ahead and erase that. There we go. And then we'll divide both sides by 36.85. And that will give us 500 divided by 36.85, $13.57. Now, probably you're not going to go up to an exchange booth and hand them $13.57. That's going to be a little bit weird, but practically speaking, you would probably exchange, say, $15. Okay. And generally, when you're traveling overseas, if you are in a situation where you have to exchange a lot of money, you try not to over exchange stuff because you either have to go and exchange it back or you end up bringing foreign currency home. Most of the time, people want to bring a little bit of foreign currency home because it's cool to look at foreign money, but you don't want to bring home like $300 in foreign money because then like you can't spend it here. So you just tend to try to limit how much you exchange. So you might hand them $15 and that would get you what you needed in order to buy what you wanted to buy. So currency exchange, second example. Percent. I love doing percents with proportions. So here's the deal with the word percent. I have a couple of short videos on this. Percent, the suffix here, I don't even know if it's a suffix. It's the second part of the root word. I don't know. Not an English major. CENT literally means 100. Okay. And just if you want to connect that, a century is 100 years. Okay. We have 100 cents in a dollar. Okay, we have 100 centimeters in a meter. A centipede, I don't know if a centipede has 100 legs or if that's just, one of those things that's close enough. But CENT means 100. And if you, in French, in the French language, cent, CENT is the word for 100. And I think it's similar in Spanish, so you might have some connections there. And so literally the word percent means per or out of 100. So how many out of 100? And we like percents because it gives us this common denominator of 100 that is easy for us to quantify. So you scored 11 out of 14 on a quiz. What percent is this? So you scored 11 out of 14 and you want to know what is that out of 100. The reasoning there is 11 out of 14. Okay, so picture your pizza. Okay, so you divide your pizza into 14 slices and you have 11 of them. 11 out of 14 is how much out of 100? So if you were to divide your pizza into 100 slices, how many slices would you have? And that number would be your percent. So let's go and solve it. So we'll cross multiply. 14 times x is equal to 11 times 100. So 14x is equal to 1100. Divide by 14. And what do we have? It does not help that I keep entering stuff in wrong. 1100 divided by 14. 78 point, we'll say about 78.6. Okay. Now you might have said, well, I had a teacher once tell me that I could do this. I could do 11 divided by 14. Okay. And then take that result and multiply it by 100. Well, look at what we did here. Okay. We did exactly that, except we multiplied by 100 first, and then we divided by the 14. So we just kind of did the same thing, just in a different order. And if you think about your order of operations, okay, multiplication and division have the same level. So you can do them in whatever order you want. So that little, do 11 divided by 14 and multiply by 100. You're doing the division first and then the multiplication. This way you're doing the multiplication by 100 first and then doing the division, and you're setting it up like a proportion. All right, next example is similar figures. So this requires some geometry. So what I'm not going to dive into in this video is why is this proportional? Okay, not going to get into that. If you are in Algebra 2 and you're watching this, probably you have had geometry, so you know that there is this thing called angle-angle similarity. If you are not in geometry yet, you have no idea what I just talked about. But when you study geometry, you study different ways of knowing whether or not different figures are going to have proportional sides. So you're just going to take my word for it that these guys have proportional sides. Now, here are the two proportional pieces. This and this is not to scale, okay? So you got that small triangle, and then you have this big triangle, okay? And what I'm going to do is say we have the horizontal side, and we have the vertical side. And you can set that up any way you want. You just cannot change your mind partway through. So in the small triangle, okay, so I'll put the small triangle here, the horizontal side was 3 and the vertical side was 5. In the big triangle, the horizontal side is 6 and the vertical side is the unknown. Okay, and so here's what I did there. So in the small triangle, the horizontal or bottom side was 3 and the vertical side was 5. In the big triangle, the horizontal side was 6 and the vertical was unknown. Now, at this point, you might be able to look at it and figure it out because of what we know about equal ratios. Remember, to get equal ratios, we just multiply by something, and you might look at that and say, aha, 3 times 2 would give me the 6, therefore 5 times 2 would give me 10, and my answer should be 10, and you would be correct. But we're going to do this with the cross multiplication. So 3 times x is equal to 5 times 6, and then 3x equals 30, divide by 3, and x is equal to 10. Okay, and I just want to do that to emphasize that you can use the proportion, but of course, if you can do it a faster way, unless you're required to show the work, more power to you. All right, so those are just some of the applications and ways that we can see proportions outside of math class, or even like this one would be an inside math class, although there are some fun applications to that. We will actually use this I'll see if I can do it. Like if you've got something that's too tall, like a tree, okay, so it's my tree over here, and you can't measure it, but you can measure, say, something shorter and its shadow, and you can measure these other 3 measurements. You can use a proportion to figure out how tall the tree is. You can also do figure out the distance across a lake and other ways of using your geometry to figure out measurements that you can't measure directly. So some pretty cool stuff. All right, just last thing, some variations. There are just tons and tons of examples of proportional relationships. You won't have to think too hard or long to come up with them. You may see variables in more than one position. As long as it's the same variable, you're okay. So you could see something like this, like x plus 1 over 3 equals x over 4. Okay, that would be totally fine. You could see 3x over 4 equals 5 over x. That's going to give you a quadratic when you go to solve it. So you would need to have some quadratic skills, but those are totally okay to do. And again, if you know what a proportion is, your skills are going to transfer over. So you would cross multiply and then you look at what you have left. You may need to use other algebra skills in the solving. So distribution, this one here would require you to use distribution. This one here would be a quadratic, and so forth. Okay, that's it. So like and subscribe if you found this video helpful. Drop a comment or question to engage, and check out the practice set for this lesson, and check out some of the other videos we have on the channel. I'll see you in the next one.